So then, if we're having functions that we want to change back and forth between rectangular form of the function and polar form of the function, uh, there are several relationships we take care of. First, x equals r cosine theta and y equals r sine theta. These are mainly used when switching from polar to rectangular. We'll also use them in a minute here when we switch from polar to parametric. Uh, the Pythagorean identity, r squared equals x squared plus y squared, uh, we use mostly for rectangular to polar, but it is sometimes used for polar to rectangular, uh, like Pythagorean identity and trig with the unit circles. It's just used a lot. And then tangent of theta equals x over y is a way that we can figure out what theta is, because then we can do the inverse tangent of both sides to get theta. Uh, so for example, let's say I have the polar function r equals 4 sine theta, which we just looked at the graph of as a circle, radius of 4. And, I'm sorry, radius of 2, its diameter is 4. And I want to change this into rectangular form. Well, seeing that I have r here, this is where Pythagorean identity is going to come in. Now, the key here is I don't really want to just square that side because that's going to cause issues on my right side if I just square it. Because 16 sine squared is not going to help me with converting to a different form. So I think in terms of, well, what am I missing on this side? On the left side, I'm missing an r. So I'm going to multiply each side by r. So now I do have r squared equals 4r sine theta. And that's a common way that we want to square r's. Instead of squaring it, we're going to multiply by r to get 2 and r squared. And so now that I have r squared, I can use the Pythagorean identity and replace it with x squared plus y squared. And what I also notice is that the r sine theta is what y is. So that would equal 4y. And then that actually is fine for rectangular form. If you wanted to put it in a more standard form, uh, I could make it equal 0, move everything to one side. If I wanted to put it in the form, I notice it is a conic. It would be a circle since x squared and y squared have the same coefficients, and I'm adding them. If I wanted to put it into center radius form for a circle, I'd complete the square on the y's. And here I would have a circle radius of 2 with a center at 0, 2. Um, Again, in terms of how we would use it in calculus, I would stop up here normally, since we don't have to do any simplifying for calculus. If I wanted to switch from polar to parametrics, uh, I take advantage of actually the whole idea of polar to rectangular. But what it is since x is equal to r cosine theta and y equals r sine theta, r is just going to be some function dependent on theta. I don't know what. And we can use theta and t interchangeably because remember, t is just an, an independent variable that x and y both depend on. Um, so if I look at the r sine of 6 theta, which we had graphed earlier, gives us 12 petal rows. If I wanted to change this into parametric form, well, this is r with x equals r cosine theta. I'm just going to replace r with this. So x is equal to whatever r is times cosine theta. And y would equal whatever r is times sine of theta. And it seems like it should be harder than that for parametrics, but that's really it. And actually, if I go ahead and graph this in parametric form, and I've already actually changed it, my calculator in parametric form, put in the x's and the y's, and if I look at the graph, I get the exact same graph. It's just in parametric form.